Hello everyone. I know these videos aren't the most exciting, but I'm just trying to inform you and give you opportunities to see problems worked out. A lot of you can just see the formula and figure out how to do it. A lot of you need to see a lot of examples worked before you can do it on your own. And either way is okay, but this is for those that need a few extra examples done for them. Okay, so let's look at the ones we're going to start with today are in your workbook. We're going to focus on the independent practices. We're going to start on page 170. It's going to be the first page we're going to go to. So if you want to get your workbook and write these in there, so you have something to kind of go back and refresh and study before your quiz on Monday, then that would be awesome. Okay, so number 7 on page 170, we have a triangle and we're trying to find the area. And the formula for triangle is area is equal to 1/2 of the base multiplied by the height. I'm hoping by this point that that's starting to sink into your head. I notice a lot of you are still forgetting that 1/2. So it's important to write it down to remind yourself that 1/2. Okay, remember base must be perpendicular to height. And so right here you'll see our base is here. And here's the only line that's perpendicular where we have numbers we know. Okay, we could use this 15 if we knew what this base was right here, but we don't. So these are the two numbers that we have, base and height. So we've got 1/2 of 25 multiplied by 4. And so 25 multiplied, I could take half of one of these numbers, but I'm really familiar with what these numbers are going to equal. So I'm just going to multiply it and then take half of it. So area is equal to 1/2 of 100, because 25 multiplied by 4 is 100, half of 100, and units, oh, this is centimeters, centimeters squared. Okay, we're also going to do number 8. So same thing, there's our formula. I'm not going to rewrite that over here. Well, maybe I will, because it's just a good habit to have. Area equals 1/2 of the base multiplied by the height. And our base is here, 15.5, and our height is 6. So 1/2 of 15.5 multiplied by 6. Area is equal to, I'm going to rewrite this, 6 multiplied by 15.5. It's easier to take half of 6. Area is equal to 3 multiplied 15.5, and 15.5 multiplied by 3 is 46.5 centimeters squared, and that's my area. Okay, the next one we're going to do is number 10. And I'm not sure if this is on this page or if it's on the next page. Right here. Okay, I chose to do this one because we're still struggling with this kind of idea of working backwards, where we're given the area and we're asked to find either the base or the height of something. So let's go ahead and write our formula. Oops. Let me switch to my pen. Okay. Area is equal to 1/2 of the base multiplied by the height. Writing my formula so I don't forget any of the parts. Filling in what I know. I know my area is 76. I know my 1/2 is going to stay. I know my base, I'm going to say my base is 9.3. And my height is, I don't know. Okay, and so now let's just figure this out. We've got 76, and half of 9.3 is 4.65, and then we're going to divide both sides by 4.65. I hope at this point you're now beginning to recognize that when you have a variable, in this case h, next to a number, regardless of whether that's any integer, positive or negative, or a rational number with decimals here, we always want to isolate this h, and so that's the number we have to divide by. So this becomes our 1, and then this becomes h is equal to 16.3. Okay? Okay, let's move on to the next one. You'll notice this video is a little choppy. I'm going to break it up as I move on to the, move the screens and stuff, so we're not taking up screen time doing that. Okay, so we're still on page 170. We're now doing problem number 12. And I've already written the formula here. So the area is 45. Okay, so area is 45. Remember, these are the ones we're working in reverse. And we want to know, we're finding our base. So we have 1/2 of the base, which we don't know, and our height is 16.6. So I'm going to rewrite this, rearrange for convenience purposes, right? So 16.6 b. So then 1/2 of 16.6. So then I get 45 is equal to 1/2 of 16 is 8, 1/2 of 6 is 3. So we have 8.3 b, dividing both sides by 8.3. And we come up with a solution of b is equal to 5.4 centimeters squared. Okay? Like I've said before in other videos, if that was fast, rewind it and go back, watch it again, see what you missed. It's the beauty of a video, right? Okay, next thing, we're going to the next page, 171. Okay, here we are, 171. We're going to find the area of the shaded region. So this part right here. So sometimes we're going to have to do different, find the rectangle first and then move from that. But in this case, we don't need to do that. So we're just going to find the area of the triangle. So we have writing our formula down. And the first thing we need is a base. Okay. And this is going to be our base right here. But we don't have a number for that. But we do know the length of this right here. And we do know that these two angles are perpendicular, which means that these two are the same length. So that means that this whole length from here, clear up here, down to here is 40. So that means this area right here, our base is 40 minus 7, which is 33. So now we know we have a base of 33, and our height right here, right, perpendicular, would go up to the highest point, which is right here, right? Or we could even use this right here. So we have a height that is 20. So let's go ahead and fill our information in. We have 1/2 of our base, which is 33, and our height, which is 20. So then I'm going to rearrange this for convenience purposes, right? Because it's easier to take 1/2 of 20. So area is equal to 1/2 of 20 is 10 multiplied by 33. And so 10 multiplied by 33 gives me 330. And these are meters squared. All right, so that we're done with that one. Okay, we're moving on to number 16 on page 171. So as you can see, I've already marked the base and the height for the two shaded triangles. What's important to solving this one is our knowledge of what these little lines right here mean. What this little line right here, what all of these mean. And then right here we have double lines, right? So when we see lines like that, that's telling us that those sections are the same length, okay? So as you can see over here on 15, which we're not going to do, but you have a double line here and a double line here, and we have a measurement of 24 for that section where that double line covers. So that means that this section here would also be 24. So when we're looking at this, you're like, well, Miss Brock, everywhere it has one of those little one line, it doesn't tell me what it is. So I have to find clues somewhere else. Pardon that. Okay, so my clue is right here. This is the only information I'm given right here, that this side is 24. So I can conclude that opposite sides are equal, right? So this length right here on the bottom, it must also be 24, but it's been broken up into two sections, right? It has two parts to it and they're equal. Those two parts are equal. And so I can assume that if those two are equal, then it's 24, right? Divided by 2, which is 12. So we can assume that wherever there's a line here, that all these sections are worth 12, right? This is 12. Okay, and by that same logic, if this section is 12 and opposite sides are equal, then that means that this whole section would have to be 12, but it's been broken into two parts, a shaded part and a non-shaded part. But those two parts, shaded and non-shaded, they are the same length. So because the double line tells us, right? Same length. And so that means that it's 12 and they're divided equally. So that means each one of these sections is 6. Okay? So if we know that each of these are 12, then we can assume that our height here, because it takes up one of these sections, right? That it's 12. And the base here goes the whole length, right? And we know what the whole length is. So we know that the base of this is 24. So now we can solve for both of our triangles, and then we can add those two areas together to get the area of the shaded section. So let's do one first. So triangle here. So area is equal to 1/2. And our base is 6, right? Base is 6. And our height is 24. So equal to 1/2 of 6. Now, I hope you know that you could multiply these together and then take half of that. That's the same as taking half of this small number up front. I'm going to get the same answer either way. So I'm going to take half of 6, which gives me 3, multiplied by 24. So 3 multiplied by 24 is 72. Okay, I could also have taken half of 24 and gotten 12 and done 6 times 12 and also gotten 72. Multiplication is amazing, right? It works no matter which way you do it. You can move those numbers around, do them in any order. Okay, so now let's find for number 2. So this is, what's our measurement here? Feet. Okay, so let's do this second one. Base and height. So our area is 1/2 of our base, which is 24, our height, which is 12. Area is equal to half of 24 is 12, multiplied by 12. Area is equal to 144 feet squared. So then we're just going to add that together. And we get a total of what? Sorry. feet squared. So our shaded area for number 16 is 216 feet squared, because I found the area of this smaller one and this larger one, and then I added those two areas together. So as you can see, I've got an area here and an area here. Okay? All right, nice work. Let's move on to the next one. Okay, moving on to page 172 and number 23. And I love this problem because when you first look at it, you're like, oh gosh, I don't know what to do with that, right? And it says, because it tells us it's a trapezoid. And at this point you hadn't learned trapezoids, so you're like, how am I going to do that? Now you're given all the information. If you knew the formula for a trapezoid, you could easily find that area, but you have enough information here with what you knew at this point to be able to solve this, because it's asking you for the shaded area. So if I remove this section right here, if I just like took it out and I pushed these two together and I just made a great big triangle, right? And so my triangle would look kind of like this, right? So here's the two sections that I had. So here's my base right here, and then my height is this distance that they gave me right here, which was 28. So how much did I remove here? I removed 24 feet. And so if I go down to here, well, my base of the whole thing was 56. So my base of my new triangle is 56 minus that middle section I just took out. So minus 24. So I'm left with a base of 32 feet. So my new triangle has a base of 32 feet. Okay. So then I just go ahead and solve that, right? So I have an area which is equal to 1/2 of 32 multiplied by 28. Area is equal to 1/2 of 32 is 16 times 28. So my area is, and remember our measurement here, is 448 feet squared. So not a difficult problem. You just have to think about, what do I know and what can I get rid of? And yeah, so I really like that problem. And when Miss Brock says she really likes something, what does that usually mean? Anyway, I'll leave that up to you to decide. Okay, let's move on to our next problem. Okay, so here we are on page 185. So now we're in section 10.2, independent practice. On this one, Miss Brock did videos where she did all the even ones for you. So I'm just going to come back through and do a few of the odd ones so you can check your work. Now I skipped these ones up here where you're just labeling base and height, but you can expect on your quiz that there will be some questions that ask you to identify the base and the height. So, make sure you understand that whole concept of base and height needing to be perpendicular. Okay, so let's go ahead and find the area of this. If I can get my pen working here, okay. So we're looking for the area of this parallelogram. So area is equal to base multiplied by the height. Well, now, although this is up top here, opposite sides are equal, so this is also 28 inches right here. So here's my base and here's my height, right? Perpendicular to each other. So area is equal to 28 multiplied by 15. Area is 420 inches squared. Okay? That should be, it's so similar to a rectangle. As long as you understand the concept of perpendicular, then you shouldn't have a problem with that. Okay, we've moved on to page number 186. And we're going to do number 11. Okay, we're finding the area of a trapezoid. I've already written the formula here. And like Ms. Brock has said, I like to associate base one with the smaller one. You don't have to. It doesn't matter. You're finding it's the sum of the two. So does it matter what order they're in? No. And you're finding the average of that, right? What's the average between 15 and 7? Because that's what you'd do, right? When you find an average, you add two things together and divide it by how many things there were, and in this case 2, which is exactly what we're doing here. So it doesn't matter what order you put those in. It's just my preference. Base 1 is always the shorter side, just so I can keep track. Okay. All right. So let's go ahead and solve this. So we've got, let's fill in our information. Area is equal to 1/2. Our height is 10. Base 1 is 7. Base 2 is 15. That added together is going to give you 22. So now we have area is equal to, and 1/2 of 10 is 5. So we have 5 multiplied by 22. So area is equal to 5 multiplied by 22, which was 110, and it's centimeters squared. Okay? All right. Moving on to the next one. Let me pause. Okay, I'm not going to do any of these problems, but let me just make a statement about this, is that for problems like this, you do need to understand this idea that I can break this down into, I could a triangle and a trapezoid. I could basically cut this in half here and then move this and it becomes a rectangle. I mean, there's so many ways to manipulate that, and you really need to understand that, especially for our next section, which is talking about composite shapes, which is exactly breaking down figures so we can solve stuff based on the information that we have. But what we're going to do is number 17. Oh, I didn't even go far enough. So we're on page 188, and we're going to do 17. And this is the same idea of moving in reverse, right? So we have our area, and for parallelogram, base multiplied by height, and we know we're going to call this our base because it's asking us to find the height. So our area, it tells us, is 64, and our height, we don't know our base. Oh, sorry, we do know our base. Let's go back one there. Okay, so our base is 7, and we don't know our height. So we're going to divide both sides by 7, always isolating that variable, right? Because that's what's going to tell us what our height is. 64 divided by 7, I get a height which is equal to 9.1, and it's inches. Okay. All right, we're now going on to number 19, so I'm just going to scroll down here. Okay, because they're on the same page. Okay, same idea, only with a trapezoid. So we've got, let's quickly write our formula down. Area is equal to 1/2 of the height multiplied by base 1 plus base 2. Okay, so our area, it tells us, is 42. And we're looking for the height. So we don't know the height. And we know our two bases. Our base 1 is 5. Our base 2 is 7.5. So we're going to add that together. And that added together is 12.5. Okay, so then we're going to rearrange this, right? I can't take half of an H. So I'm going to put 12.5 here. And there's a far more complicated way that you could do this, but this is the easiest way, okay? Just rearranging. So half of 12.5 gives me 6.25. H, divide both sides by 6.25. 6.25. And I come up with a height And remember, you're rounding your answer, round the nearest tenth. So that is right here, right? That's your 1 decimal place after, okay? So we're going to, let's see, our height on that is 6.7 once I round. It's a 6.7 on that. All right, let's go to the next one. Okay, we're ready to do number 21 on page 188. Okay, so it says the area of trapezoid ABCD is 503.25 square centimeters. It says it wants us to find the length of BC. So we're looking for this length down here, right? We're looking for the other base. We're looking for base 1 as far as Ms. Brock's concerned because it's the shorter side. Okay, we haven't done one like this, at least I haven't demonstrated one like this, so I'm glad that we're doing this one. Okay, so I've already written the formula out here, and I filled in all the information that we know. Here's our area, we have our height here, and then what we know of our bases, okay? So my first step is I'm going to find half of 18. So let's rewrite this, 503.25, and half of 18.3 is going to give me 9.15, okay? Multiplied by base 1 plus 34. Oh, sorry, I just sneezed. Okay. So now we need to get this by itself, right? Because this is multiplied by the whole sum. I can't just subtract this over from here because that's multiplied. And I could do this a few different ways, but I mean, I could distribute this and then subtract it from that. But the way that I'm going to do it is my preferred method, okay? So what I'm going to do is I'm going to divide this whole thing by 9.15, right? So that's going to become 1. So if I divide this, I get 55 is equal to, and I don't need the parentheses anymore, base 1 plus 34. So now to get base 1 by itself, right here, looks like a 6, sorry. I just have to subtract a 34 from both sides, right? So this cancels each other out, becomes 0, so I'm left with base 1 is equal to 55 minus 34 is 21. So our base is 21 centimeters. Okay, and that's what it was asking. So BC, line segment BC, is the same as 21 centimeters. That was a fun problem. I like that one. Okay, let's go on to the next page. Okay, we're now going to use a coordinate plane here, and we're going to plot these points and find a shape that we can then find the area of. So it says 3 out of the 4 coordinates on, oh wait, that's 24. We're going to do 23. I already did 24. Okay, use the coordinates, the vertices. Vertices, remember, is another word for corner. So find the coordinates for the corners, or vertices of the parallelogram, are as follows: P, Q, R, S. Find the area of the parallelogram. So let's just go ahead and let's plot these points. So we've got P at 0 and 5. So that's going to be right on the y-axis right here. Okay, so there's P. Q is -3 and 0, so that's going to be right on the x-axis right here. So that's Q. And then we've got R at 2 and 0. So that's right here. And then we've got S at 5 and 5, over 5, up 5. So there's our S. So then you're just going to plot these, connect these up. My drawing's not super awesome on this pad, sorry. And then we're just going to find the height, the base, 1, 2, 3, 4, 5. Notice I'm counting spaces. I'm not counting the numbers, I'm counting the spaces. So here's 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces. So our base is 5, and counting the spaces up, 1, 2, 3, 4, 5. So we also have a height of 5. So area is equal to base and height. Area is equal to 5 multiplied by 5, or the area is 25 units squared. Okay, done. Okay, let's go on to number 25 here. The coordinates of the vertices of a trapezoid. Here's its identification. E, F, G, H, R, and there's your points. Find the area. Okay, so let's plot these points. -3 and 3, -3 and 3. There's our E. F, -3 and 0. So this is F. G is 1 and -4. That's our G. And our H, 1 and +4. Okay, so we're just going to connect them up. Yikes. I apologize for my shape not being super awesome. Okay, and so I have my base 1 is going to be 3, counting spaces, right? 1, 2, 3. My base 2 at 1, 2, 3, 4, 5, 6, 7, 8. So my base 2 is 8, and my height is 1, 2, 3, 4. So right here, right? That's going to be 4. Okay, so formula, area is equal to 1/2 of my height multiplied by base 1 plus base 2. Fill in our information. 1/2 of our height, which is 4, plus our base 1, which is 3, plus base 2, which is 8. This added together, 8, 9, 10, that's 11. Area is equal to 1/2 of 4, 2, multiplied by 11. So my area is equal to 22 units squared. All right, 27. Let's scroll down here. Doesn't let me scroll down if I'm in writing mode. All right, 27. What is it asking us to do? Let's get rid of this grid. We don't need that anymore. So let's erase and let's expand. Okay. The parallelogram of PQRT, so that big parallelogram, is made up of an isosceles triangle, PST, that's the one in the top right corner, and a trapezoid, PQ, R, and S. It says it wants to find the area of the parallelogram. And this is one of those problems where they just give you a bunch of information and hope that it freaks you out, okay? So what it's asking us to do is to find the area of the parallelogram. And the formula for that is area's base multiplied by the height. Okay, well, what is my base? Well, my base would be like right here, okay? Well, I don't have anything there, Miss Brock. Well, opposite sides are equal. Well, Miss Brock, all I know on that side is 5. No, you don't. Remember the little lines we talked about earlier? So that means this and this are the same, which means this is 15, which means that the whole side here is 5 plus 15. So my base is 20. And what is my height? Well, my height must be perpendicular, right? opposite sides are equal, so this is perpendicular to this, which is the same length as this. So my height, right here, 14.5. Please don't get mistaken and think that this angled line is the height, okay? That's a distance. Okay, so we have area is equal to our base of 20 and our height of 14.5, and let's see, area is equal to 290 centimeters squared. Okay, so don't see this and think, oh no, so much math. Really, it's not. You just have to decipher what information is important and what's not. They're just saying, hey, look, I can break this up into different shapes. And I'm going to give you some information about each one of them. Okay? So focus on what you need to know and if there's a way you can get that information without having to do as much math. Right? Mathematicians, lazy. Miss Brock's motto. Okay, so let's go ahead and erase this and we're going to go on to... Okay, so now we're on to number 29 on page 190. So it says trapezoid ABDE is made up of 3 triangles, and figure ABCE is a parallelogram. Find the area of triangle EBC if the area of a trapezoid ABDE is 180 square centimeters. Okay, so here we have our formula for a trapezoid because it wants us to find the area of a triangle, and the area of the triangle it wants us to find is this one right here, E, B, and C. But we don't have any information for any of the sides for E, B, and C. I mean, we do have a height, but we don't have a base and we don't have the area, so there's no way we can find what the base is. But we do know what the area is for this, and we know its height, so we can work with that. So let's fill in the information that we have, okay? So we know that the area is 180, and 1/2 is going to say, and we know what the height is. The height is 12, but we don't know what base 1 or base 2 is. Okay, so let's 180, let's simplify this. That's going to give us 6. All right, so we've got, now, same thing we did on that problem a couple problems ago. We are going to divide this whole thing by 6. We're going to separate that 6 from the B1 plus B2. Okay, so that gives us 30. 180 divided by 6 is 30. And this is going to become 1. So we're left with B1 plus B2. Okay, so you're like, oh, well, there's 2 B's there. But remember, they're not the same length, so I can't treat those. One is B1, one is B2. Those are not like terms, right? So I have to change them so that they are like terms. So B1, I can leave that, right? B1. B2 is, oh, look, it's just like B1, but it's plus 6 more. So plus a B1 plus 6 more. Okay? So now I can combine like terms, right? 30. I have 2 B1s. Oh, 2 B1 plus 6. Okay, now I need to get rid of the 6. So I'm going to subtract a 6 from both sides, right? I need to move it. I'm trying to isolate this term right here. So then I've got 24, 30 minus 6 is 24, is 2 B1s. Okay, so then I can divide to get the B1 by itself. So B1 is 12. Okay, so if B1, that was this original one, is 12, and we know that these are the same, right? We also know that this is going to be 12. So now we have the base and the height of the triangle, which they wanted us to find the area for, triangle EBC. So the area of EBC is equal to 1/2 of the base of 12 and the height of 12. So is equal to 1/2 of 12 is 6. So EBC is equal to 72 centimeters squared. And that's your answer right there. Okay, let's look at the next problem. Okay, last problem in this video that, sorry, is going longer than I had planned. I hope pausing would make it shorter, but okay. So we have here, it says use graph paper. So I've pulled the grid up here. You can find grid like this online. So go ahead and look for one. You can plot it online, make it easier for yourself. So plot points P, Q, R, S, and T on the coordinate plane. Join the points in order to, so in order, which they mean in alphabetical order, of P, Q, R, S, T. Find the area of that figure. Then part C is point V, so some point they haven't given us, lies along line QT. The area of the triangle PQV is 2/5 of the area of the triangle PQT. Give the coordinates of point V. Plot point V on the coordinate plane. Okay, so let's deal with A and B first. So let's plot those points, -2 and 2. Oh, get my pen first. Okay, -2 and 2. So there's P. Q, -2, -2. So here's Q. -4 and -5. Okay, -4 and -5. And then and that's R. And then we have 1 and -5. So we're right here, and that's for S. And then I have point T, which is at 3 and -2. Okay, so there's T. So let's connect those up in order. I've got and we're going to go all the way from here to here. Okay, so there we've connected our points, we've made our figure best that I can on this thing here. So we want to find this area. Well, to do that, I have no formula to find this area, do I? No, absolutely not. So I'm going to divide this up into two things. So I've got a triangle and a parallelogram. So area for a triangle, and then an area for the parallelogram. Okay, so let's do this one first. Base, counting spaces, 1, 2, 3, 4, 5. So I have a base of 5. Okay, and I have a height of, count 1, 2, 3. Okay, so it's 15. So I have an area of 15 in my parallelogram. All right, 1/2. What is my base? Well, it's going to be, count 1, 2, 3, 4, 5. It's the same as the other one. And my height, 1, 2, 3, 4. A height of 4. And I find it easier just to multiply these, you know. So we have 1/2 of 20. So I have an area of 10. So my PQRST is equal to 25 units squared. Okay, so there I found the area of my whole thing. Now it tells us in C. So this is A, right? We plotted it. and this is B. We found the area. So now we're trying to do C, okay? We're trying to find point V, and it lies along QT. So it's somewhere on this line here, okay? So somewhere here in PQT, we have point V, so it's going to make some kind of smaller triangle here, right? Some kind of, maybe, let's just imagine, you know, maybe we have a triangle that's going to go right here, okay? All right, but we don't know where that's at. So it says that it is 2/5 of the area of the other triangle. Well, that's this right here. Okay, so V is equal to 2/5, wherever it is, of that area. Okay, so 2/5 of, multiply, of 10, 2/5 of that area of 10. Okay, so I'm just going to change that into a fraction. So I get 20 over 5. So I find out that the area of that triangle PQV is 4, right? 20 divided by 5 is 4. Okay, so now I need to figure out where that point is. I know the area is 4, but I don't know where that point is. So I don't know what the base is. I know what the height is, but not the base. So I'm going to come up here. So we're going to say this is for PQV, right? So area is equal to 1/2 of the base multiplied by the height. The area is 4. The base is I don't know, and the height is 4. Rearranging 4B, oops, 1/2 of 4. So that's 2B. Divide both sides by 2. We have a base of 2. Okay, so we have a base of 2. So from point Q, I'm going to count over 1, 2, and I'm going to put my dot right there. Oh my gosh, it's almost like I knew where it was going to be. Okay, so this is my triangle right here. And so my coordinates for that point, so point V is, right, it doesn't go anywhere. It stays on, right on the y-axis, so it doesn't go left or right, so it's 0. And then we go down -2. Okay, so that is how you solve 31. Let's see if that's our last one. I just want to double check. And yes, it is. So please study your independent practices, because if you can do those problems, you can do really well on the quiz on Monday when you finally take it. Good luck. Bye.